Have you ever had one of those weeks where the days just fly by
Oh, absolutely.
and you think, wait, are the days actually getting shorter or does it just feel that way?
Well, it's funny you ask that. It's not just a feeling.
Okay, let's unpack this.
Yeah.
Because according to the sources we looked at, the length of a day is, in fact, fundamentally changing.
It is. We're talking about real, quantifiable data.
And it's not just a simple trend, right? The Earth is speeding up and slowing down.
Exactly. And what's really fascinating here is the precision scientists are using to track it.
How precise are we talking?
We're talking down to the millisecond.
Wow.
Yeah, and that level of hyper-accurate observation tells you this is a real phenomenon and one that's significant enough to warrant that kind of close watch.
Okay, so we've established it's happening.
Yeah.
But the big question the sources get into is, why? What's making the planet's rhythm change like this?
Well, it's a really complex interplay of forces deep inside the planet.
Deep inside, so not on the surface.
Right. Most of this variance is linked to the transfer of angular momentum between the solid Earth and its fluid layers.
You mean the core and the mantle?
Exactly. The movement of all that matter deep, deep down is what's causing these tiny shifts in our daily rotation.
That makes it sound so massive. But for the average person, I mean, a millisecond, how does that actually create a problem?
Well, that's the thing. It seems tiny, but it has this huge cumulative effect.
Okay.
The Earth's rotation, that gives us universal time. But our entire technological world,
You're on atomic time, which is constant.
which is perfectly constant, and when those two drift too far apart, when all those milliseconds add up, they have to be synchronized.
And that's the leap second.
That's the leap second.
And here's where it gets really interesting in the source material. It sounds simple, just add a second, but it's an operational nightmare.
It's a massive coordination effort. I mean, think about it. The last time they did this back in 2016,
Yeah.
it caused all these significant networking failures
In what kind of systems?
in everything that relies on perfect global timing. So GPS, satellite communications, even major parts of the internet infrastructure.
All from 1 second.
All from 1 second. So a shift that we only measure in milliseconds now is forecast to have these massive consequences over time. We're constantly having to adjust our global clock.
So what does this all mean, really? The big takeaway is that the length of a day isn't this fixed, solid, constant we all assume it is.
Not at all. It's a dynamically tracked variable.
And it has these very real-world implications for all the tech we depend on. It's kind of a reminder that even the most fundamental things are constantly shifting.
Yeah, it is. And, it raises a really interesting final question for you to think about. If scientists are this concerned about the immediate massive consequences of just a few milliseconds in the present day, what does that imply about geological time?
Like over millions of years.
Exactly. Imagine the colossal slow-motion changes already built into Earth's past or its future, just from these tiny rotational shifts adding up year after year for eons. It really puts a whole new spin on what we call deep time.